In our experiment, we isolate a room's resonant frequencies using an automated system built in Pure Data. An initial burst of pink noise is sounded, which is then filtered down over several delay iterations as the resonant frequencies reinforce themselves within the room. Other sounds fall below the noise floor, leaving only spectral elements of the room's resonance within the delay loop. This process can be thought of as a controlled feedback system. We use pink noise because it contains an even distribution of frequencies, exciting room modes quickly. Different from white noise, pink noise contains an equal power at every octave, meaning it is more ideal for this situation as lower frequencies take more power to produce than higher ones. In our experiment, we predicted that positioning the microphone in different spots within the room would lead to different resonances within the delay loop. This would be due to the location of pressure antinodes, where a resonant frequency is reinforced. If the resonance within a spot matches the predicted value using a room mode calculator, this would be evidence that the delay loop is in fact causing resonance. Here's a demonstration of how the system works. The user first sets the window size and wait period, which together determine the total loop time. The window size determines how long the pink noise seed is sounded for. The wait period determines how long the system will wait in silence before the next iteration. Longer wait periods ensure that no residual frequencies are remaining before the next capture. Ideally, this would be the RT30 of the room.
All right.
Alright, running the test.
Local device not found. Ready to pair.
It's on, yeah.
Alright, running the test. Hold on a second.
All right, rolling.